Greetings and welcome to our next unit, Unit 12, in our Big Ideas book. Unit 12 is a continuation of Unit 7 because we continue to talk about angles and triangles, and we're going to talk about polygons. So page 528, 529, and 530 this time. 3 pages, all talking about what we're going to do today. Finding the measures of many types of angles, all formed when parallel lines are cut by a transversal. Our essential question, how can you describe angles formed by parallel lines and transversals? So you should have a relative idea of what we're talking about, because you've read page 528, you've written down your notes on parallel lines and transversals, and on the first angle relationship that we want to talk about, that being corresponding angles. So let's remind ourselves what we already know when two lines intersect. When two lines intersect, we have 4 angles that are formed. We have vertical angles, we have adjacent angles, and we have supplementary angles. Remember, 1 and 2 are going to be vertical because they are opposite each other. When 2 lines intersect, they are also corresponding, so 1 equals 2. 3 and 4 are also vertical, they are also congruent. And then you have the 4 pairs of adjacent angles that are also supplementary, meaning that together they form a straight angle, which is equal to 180 degrees, and you can use that to find a measure if you need to. Well, now what we have is we have 2 lines that are parallel. All right, so right now you have line P and line Q, P and Q. So P is parallel to Q. How do I know that? Because it has those parallel arrows. Just like on figures that say opposite sides are parallel, we can have these 2 lines that are parallel. So P and Q are parallel, still cut by that transversal T. We call it a transversal because now it intersects more than 1 line. Okay? That's the definition of transversal, a line that intersects more than 1 line when those lines are parallel. All right? And as you can see, we can now recognize some angles that we can call corresponding. Corresponding angles, by the book, if you read and wrote it down, are angles that lie on the same side of the transversal and are in corresponding positions. So let's talk about it. You can obviously see that this angle 4 up there is the same as this angle 4 here. It's got 4 red marks. Those are in the same darn position. That's still angle 4. So if angle 4 is angle 4, then those 2 angles better be equal, meaning that corresponding angles are congruent. Angles that are in the same position when 2 parallel lines are cut by a transversal on the same side are congruent. So corresponding angles, write this down, corresponding angles are congruent, if you haven't already, meaning they are the same measure. So you can see if I were to cut out these 4 angles right here, if I were to cut them out and slide that whole thing down, that they would be right on top of themselves in the second set of 4 angles on line Q. So now we can use corresponding angles to find measurements of other angles, like we're going to do right here, finding the measurement of angle 1 and angle 2. So we have 2 parallel lines. A is parallel to B, cut by transversal T right here. And we can see that this angle is 99 degrees. Using what we just learned, if I were to cut this out and put it on top of the other, we would see that 99 and angle 1 are in the same position on the same side of the transversal, so they are corresponding. That means they are congruent. So the measurement of angle 1 has to be 99 degrees. And then we can see that angle 2 and angle 1 are supplementary. They form a straight angle. So taking 99, subtracting from 100, we find that the measure of angle 2 is 81 degrees. Moving right along and doing that one more time. Again, A is parallel to B, and we want to find the measurement of angle 1 and the measurement of angle 2. And we can see that 65 is in the corresponding position to angle 2. So now this time, angle 2 is 65 degrees. Angle 2 and angle 1 are supplementary to each other. They form a straight angle, and so they are equal to 180. So when I subtract, I get 115 degrees for angle 1. Moving along this time, using the figure to find the measure of all the numbered angles. Well, we want to find, let's see, there's 7 of them if I look real quick. So we're going to find the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle 4, the measure of angle 5, the measure of angle 6, and the measure of angle 7. Wow, that's a lot we're going to find, and we're only going to use what we've learned so far. So right now, I'm going to use our new found knowledge of corresponding angles to say, hey, 68 and 6, they correspond. So since 68 and 6 correspond, that means angle 6 has to be 68 degrees. Now, utilizing our fact that we have other things that we know. 6 and 4 are vertical, 68 and 1 are vertical, so that means angle 1 has to be 68 degrees. And angle 4 has to be 68 degrees. So there's 4 angles in this picture, 2 parallel lines. By the way, we didn't write that down, but A is parallel to B, cut by transversal T. There are 4 angles that are all 68 degrees, 4 angles that are all the same. Now we can use anything we learned from before, like supplementary angles. Let's go right here. And we have angle 3. Angle 3 is supplementary to the 68. So if we subtract that, if we subtract those 2 angles, or subtract 68 from 180, we would find that angle 3, let's use a different color. Let's go with red. Angle 3 has to be 112 degrees. Okay? Well, if angle 3 is 112, it corresponds to angle 7. So angle 7 has to be 112 degrees. Angle 7 and angle 5 are vertical, so angle 5 has to be 112 degrees. Angle 3 and angle 2 are vertical, so angle 2 has to be 112 degrees. So, now it's easy for us to find all those angles solely and purely on the fact that we know vertical angles, supplementary angles, and now we know corresponding angles, angles that are on the same side of the transversal in corresponding positions, which are congruent. They're the same. That's the end of this first video. Please, you might have to pause so you can draw this quick picture of parallel lines A and B cut by transversal T, and you're going to find the measure of all 7 of those angles, knowing that this one angle right here is 41 degrees. So if you need to pause for a second, great. Get that drawn. It doesn't have to be perfect. Okay? We're going to make a quick drawing, and then you can say that A is parallel to B so that you know that's to be true. Cut by transversal T, and then away you can go. If you want to use a straight edge and a ruler, that is absolutely wonderful. I'm not going to tell you not to. As soon as you're done with the quick write, take a quick break, come back, and we have video number 2, where we're going to learn some other special angle relationships.